All right, let's talk about something that stumps even the absolute brightest students out there: physics. We're going to unlock a fundamental shift in thinking that can take you from just getting by to achieving true mastery. So let's just start with the big question. Why is it that so many smart, hardworking students hit a total wall with physics? It's a really common frustration. But you know what? The reason might not be what you think. Okay, let's dive right into it. The biggest barrier isn't that physics is just impossibly difficult. Nope, it's actually a very common and very tempting learning habit that's quietly sabotaging your progress. Let's call it the shortcut trap. This quote just nails it. The problem is relying on memorization, on finding these clever little tricks or jagad, hacks or shortcuts to get to an answer without actually understanding the principles. Sure, you know the formula, but do you really know the conditions where it applies? And more importantly, where it doesn't? Think of it like this. Memorizing formulas is like trying to find your way through a huge, dense forest by memorizing the look of specific trees and rocks. It might work for a little while, but if you start from a slightly different place, or if the path changes just a little bit, you are completely and totally lost. So, if memorizing landmarks is the trap, what's the way out? Well, the solution isn't just another shortcut. It's a complete shift in your mindset. It's about throwing away that list of landmarks and instead learning how to use a map and a compass. And this right here is the core philosophy. You have to stop chasing the final answer and instead fall in love with the process. Excellence in physics comes from mastering the systematic, step-by-step method of thinking through a problem. The how is infinitely more important than the what. And here it is, the golden rule. Every formula is a tool, not some magic spell. If you can't derive it from the ground up, from first principles, you don't truly understand its assumptions or when you should apply it. Rederiving fundamental results, like the time period of a simple pendulum, until they're second nature, that's how you earn the right to use them. And this table just brilliantly illustrates the two mindsets, doesn't it? The lost student depends on shortcuts, memorizes landmarks, and is basically trapped by their formulas. But the master navigator, they focus on the process. They use their map and compass, those first principles, and they can find their way from absolutely anywhere. Okay, so having the right philosophy is a great start, but you need practical tools to actually execute it. This is where we learn to master the terrain with the analytical method. This is your technique for navigating any physics problem that comes your way. Before you even think about writing an equation, you have to read with absolute precision. So many mistakes come from just missing a single constraint in the problem, a little phrase like small loop or frictionless surface. That one detail can make your entire solution invalid. This is why you should always draw a clean, detailed diagram. In mechanics, it helps you actually see the line of action of forces and find the best pivot points to make your torque calculations way easier. Now, this is a perfect demonstration of the method. Instead of trying to find one big, general shifting formula for a complex optical system, the master navigator breaks it down. They analyze what's happening at the very first interface, they find the image, and then, here's the key, they treat that image as the new object for the next interface. It's a systematic, foolproof process. These are your power tools. When you're stuck, don't just hunt for another formula. First, go back to first principles. Ask yourself, what's the fundamental cause here? For instance, buoyant force isn't just a formula. It's caused by pressure gradients. Understanding that lets you solve problems in, say, accelerating frames, where the standard formula completely fails. Next, use symmetry and superposition to break down complex systems, like resistor cube networks, into much simpler parts. And finally, use calculus to analyze variables. Build a function and find its maximum or minimum instead of just guessing. So you've gotten an answer. You're not done yet. The final, absolutely non-negotiable step is validation. You have to step back and ask a really simple question. Does this answer make any sense in the real world? Here are 3 quick ways to do a sanity check. First, dimensional analysis. Do your units even match up with what you're trying to find? It's a lifesaver. Second, check the limiting cases. For example, if you have a formula for a bimetallic strip, what happens when the expansion coefficients are equal? Well, it shouldn't bend. If your formula doesn't show an infinite radius, you know it's wrong. And finally, the beauty check. A correct physics equation often has a certain mathematical elegance. If your answer looks like a total mess, you might have an algebra error. So, now you have the philosophy and the tools. But how do you apply all this effectively during the storm of an exam, when the pressure is on and that clock is ticking down? First, you have to change your relationship with mistakes. An error isn't a failure, it's a data point. It's telling you exactly where the gap in your understanding is. The goal isn't to be perfect, it's to learn strategically from every single error you make. And this is how you do it. Keep an error log. Every time you make a mistake, log it and categorize it. Was it a calculation error? A concept I misused? Did I just misread the question? Then, and this is absolutely crucial, revise your error log daily. Lapses on those basic concepts you thought you already knew, those are the most harmful to your score. Your mindset during an exam is just as important as your knowledge. Treat it like a sport. Focus on playing the game, on tackling each problem methodically, not on the final score. Panic causes a kind of short-term memory loss where you just go back to plugging in formulas blindly. Stay focused on the question right in front of you. Finally, be strategic. Go into any exam with a game plan for your time. This chart is just one example, but the key is to know which subjects need more focus and to protect your time for the high-scoring subjects, which for many people is physics. And just as important, have the wisdom to know when to skip a question. It's way smarter to leave one time-consuming problem and bank points on questions you know you can solve. So, to bring it all together, let's go back to our forest analogy one last time. Real success in physics isn't about memorizing the location of every single tree, every single rock in a vast, confusing forest. It's about learning to use your map and your compass, those fundamental first principles and the analytical method. Because when you have those tools, you can be dropped anywhere in that forest, and you will always be able to find your way. And that leaves us with one final thought to reflect on. Take a hard look at your own learning process. Are you spending your time memorizing landmarks just hoping you don't get lost? Or are you investing the real effort to learn how to use the map? The choice really is yours.